Hello, everyone, and welcome. It is another episode of the MetBull update. And actually, this is part one of two because Sue is going to wrap up a lot of activity of 2023 so far. There's been a lot going on in the Meteorological Bulletin database. So I'm going to let her explain exactly what that is. Just remind you guys exactly what it is and then get right into her presentation. I already have your first slide up, baby.
Okay.
All right, so tell us a tiny bit about what the MetBull is, because we call it the MetBull, but it's Meteorological Bulletin Database.
Correct. And this is the database that is maintained online for all of the approved and published meteorites that have been classified by scientists. These are not just personal finds that people enter in themselves. These are authenticated by science. There's about a little over 70,000 of them right now, with many more coming in the pipeline. So let's get started. As Topher said, this is part one. We're going to go over the basic numbers, the locations, the classifications, the new classifications, the witness balls, and things of that nature. And then we'll come back again and revisit the MetBull here in the next few weeks. And we'll hear from Pat Brown at that time and some of the things that he learned at the MetSoc meeting in, I believe it was in LA. And that is a yearly meeting. And you get to hear all of the new exciting things that are happening in the meteorite field.
And actually, the MetSoc is short for Meteorological Society, and they are part of the governing body of meteoritics. The nomenclature committee is within that MetSoc, and that's who runs the MetBull. Back to you, Sue.
Okay, so for the MetBull update that I'm about to present to you, along with Allison's help, one of our favorite crew members, the data is based on everything that has been approved and published starting in January of 2023, all the way through the July 29th update. And anything that's been approved since then, which I know there have been some updates, we will be covering in a future MetBull update. So first, we're going to cover the revisions and reclassifications. So these are meteorites that were not approved in 2023. They were approved sooner, I think most of them. And right now we're coming back, the scientists have come back and they are updating things like the total known weight or changing the classification because, there was better testing, also updating locations and coordinates. Okay, so for mass updates, there were 3 meteorites that we updated the masses on, and that was NWA 15094, and that is a classification of one of our the friends of the crew, Jason Whitcomb, and he had, there was a mistake made on the mass. I went and asked him about it because I was very curious about why some people will go through the trouble and get things updated. Sometimes other people don't. He is very meticulous and keeps all of his classifications as accurate as possible, and has some great classifiers that he works with that he really respects and prefers. He said there was a minor mistake in the mass, and he hadn't planned on selling this, but he knows that in the future, if he does, he wants it to be accurate. So whoever does decide to buy it, they can trust the information that they're seeing there. So I thought that's really awesome that he followed through on that. All right, and so lastly, I wanted to discuss Twanberg. And I'm going to go a little bit more into detail with Twanberg. So this one was found over 100 years ago in Sweden. It's still only one of 6 irons that have the IIG classification. It was found in a barley field after a farmer was plowing it. People continue finding more of this meteorite as time goes on. And so they've been really good about documenting all the additional finds. And so if you go to the MetBull, you can find a list that has almost 2,100 entries for all the Stringfield finds. And it lists the people that found it, the size, the date it was found, I think there are coordinates on a lot of the entries. So it's really meticulous. And if you look at the timeline that I put together here, you can see that this is the 5th update for the Twanberg mass, the total known weight. You can see that one of the updates was really small, but they've just been really good about getting the exact weights. As you can see, like some of these are 3 decimal points on the exact weight that they're updating. And I think, and now at the total known weight of almost 153 kilograms, I believe this is the largest of the IIG irons as far as available mass. Now I'm going to ask that Topher actually show our Twanberg because we have one in our inventory, and it's a really interesting specimen because it also comes with a booklet that I believe may be written in Swedish or German,
Yeah.
but it's really cool, and it has that list I was talking about with all the Streamfield members. It may not be the most up to date, but it is up to date as far as what the copyright date is on it. So I'm going to let Topher take that away.
Yeah, it's actually really cool, and it's connected to the piece I'm going to show you. So we're going to switch over to a video we shot about a week ago before technical difficulties. But yeah, here you go. This is the COA for it. I'm trying to find, the weight right here is 24.76 grams. What is super cool about this one is that his name is probably on the Streamfield name that you were finding. Here's the actual piece. It is the 26.5 gram piece. What's super cool about the Twanberg, which makes the updating of the MetBull, I guess, a lot easier, I would imagine a lot easier, is right here you'll notice that it has a mass number. So this happens to be sample number 248, and it's part 5. So of this meteorite probably had 5 slices or 5 pieces cut out of it into a total of 5 pieces, and this is one of them. So
did you say 248 or 548?
548.
Okay.
And it's 548-5. So here's the Twanberg 2G meteorite. I have it in here with a bunch of desiccant, so I'm not going to open it up and take it out. But what's super cool about it is it also comes with this book, which is in foreign language to me. But the super cool thing is you can come back here and check out your number. So we're looking for number 548. And here is 548. The piece was originally 258.7 grams. And there's the find location and who found it and the date. And it is meticulous for every piece.
Yeah, that's the list I was talking about. That's published on the Met.
Fantastic. So those two things belong together, and they're only going to be sold together. So Sue, back to you on locations.
Yeah, no asking us if you can just buy the booklet. Sorry, just had to throw that in there. Okay, so for our next set of updates or reclassifications, we're going to look at the location and coordinate updates. There was one for Wedderburn, and Wedderburn is a pretty simple one. It's just a 5-kilometer difference. Someone was just being really meticulous and decided to get that recorded. Then we go to Renazzo. Now, Renazzo, I don't know exactly when, but we just recently had the 200-year anniversary of this witness fall from Italy. I think it's pretty cool. So I'm including a link to a 6-page research paper, and it's all about how they were able to go back and look at old notes, like you can see here on the screen. I can't read that because it's not English. It's just really cool. The scientists have taken all these old documents and dug into them. And you can find out more details about this and how they determined how to change the impact point of the Renazzo meteorite 200 years after its fall. So
Wow.
pretty interesting stuff. And then the last one that I wanted to talk about as far as the location change is Comanche Creek Reservoir. So this one had a location change and a name change. It also has gone through 4 classification changes in the past, as you can see, from IIA to IIAB anomalous, back to IIA, and then finally on iron, IIAB, the official classification in today's nomenclature. The reason that this one changed, it's pretty interesting, and it's about time on this one. So this one was previously named Squaw Creek, and if you don't know, it's a derogatory term as far as Native Americans are concerned. As you can see, I have just the beginning, an excerpt from an article, and it's from the Interior Department. They're talking about how they're taking the word squaw out of over 650 geographic locations, out of respect for our fellow Americans. I think this is a great move, and I think that the Comanche Creek Reservoir is a much better name for this meteorite. So the last changes and reclassifications, we're going to talk about 4 reclassifications. Starting with Mount During, this one was just a very minor change. It was changed from a palisite to a palisite main group. The reason that was changed was because there's better technology now. There were new measurements taken. They adopted a new laser fluorination approach. So they were able to get better numbers and just more accurate information. It's definitely better to go from palisite to palisite main group. Another change that was made was to NWA 13498, and that one went from a type L to an LL3 with an estimated subtype of an LL 3.2-3.5. And we know that Pat probably wants a piece of that stuff. Sorry, Pat, I have to pick on you. We know you love your LLs. There was previously a magnetic susceptibility error, and so the size of the chondrules were not measured correctly. And when they went back and remeasured, they found that the size of the chondrules were consistent with a type LL instead of L. Our next classification change was, and I'm not exactly sure how to say this, so I'm sorry if I butcher it, but it's a Germania. I believe this is a witness fall. It went from an H to a stone to H to an H3-6. And lastly, NWA 773. This one went through some very interesting changes. It was initially classified as a lunar. Then it went to an OL Neurite, which I believe is olivine. Then it went to lunar cumulate olivine norite with regolith breccia. That's the whole entire classification, quite a mouthful. And now it went to lunar norite, and finally it's been settled as a lunar gabbro, and that is way easier to say, way quicker.
Well, finally, as of today, we'll check back in 2 or 3 years with you.
After we take the reclassifications and corrections out, we are left with 1,233 meteorites that have been approved and published so far. Woohoo! Woohoo! Now, 3 of those are witnessed falls, everybody's favorite. The first witnessed fall is Koshigaya. And as you can guess, that one was a witness fall in Japan. And this one is really interesting. This one fell over 100 years ago. It just has a basic L4 classification. It's about a 4 kilogram single stone. It's rounded. It's almost fully covered with fusion crust. I think the only place on the stone that it's not covered with crust is the impact spot. So Koshigaya, what makes Koshigaya really cool is that it landed on the Nakamura family farm. It's stayed in the family for over 100 years, and was not classified all at that time. But they were able to get it classified as a witness fall because it was documented in a newspaper about 2 months after it fell, the Tokyo Asahi newspaper. So I think that is pretty awesome. To have documentation from 1902 be able to get you an approved classification in the MetBull, here in modern times.
Yeah.
Then we have, here's another mouthful, Puli Ilkaranguri. As you can guess on the map, that's from Australia. So the cool thing about this one is that it was witnessed in 2019. Now, if you take a look at the map, you can see where I put a little red, dropped a little pin there. So before I get into the map, I was going to say that this is it's a small witness fall. It's under 400 grams, and it's just one single stone, gumdrop shaped. It was covered in like blackish gray fusion crust and has lots of nice ablation crack cells on it. But the really interesting thing is the location. So on the next map, you can see on the very edges down in the right bottom corner, that's where most of the population of Australia is. And then you can see there's other parts that are around the border of the continent. But a lot of the land within the inside is uninhabited. Based on some of the videos I've seen of the spiders and snakes and all sorts of critters that the crazy Australians have down there, I don't blame people for not wanting to live out there. Where it fell is somewhere that is just not inhabited. So it's not in anybody's backyard. So this was a fall that was tracked by the Desert Fireball Network. And the search party was organized, and they went out 8 months after the actual fall. The crazy thing is, it was found within 2 hours of the search party getting out there. So I thought that's pretty cool.
Wow, that's crazy, man. They
Yeah,
must have had some. Well, they spent 8 months collecting good fall data, I bet.
Oh, yeah. All right. So for this next one, I'm going to let Allison butcher the name of this one. This is the third witness fall. The third. There were only 3 so far that have been published this year. But over to you, Allison.
Thanks, Sue. Yeah, I'm really excited to tell everybody about Saint-Pierre-le-Vigier. I'm not sure if I pronounced that right. I don't speak French.
It sounds good to me.
Oh, yeah. This was a fall. It fell in Normandy, France, or thereabout, on February 13th of 2023. It was classified as an L5-6 chondrite, and its total known weight is a mere 1,200 grams. Yeah, so I'm going to get into a lot of this detail that Topher has up here on the screen, but I'm going to do it in a little bit more story form, but I will hopefully touch on all of these subjects as I go. So on Sunday, February 12th, an NEO only 3 feet wide was discovered by an observatory in Hungary, and it was confirmed by another observatory in Croatia. The European Space Agency was notified, and they alerted the public of this spectacular and safe event through social media. It reached its peak brightness magnitude of 13, the brightness about of Pluto, right before it entered the Earth's shadow, where it faded dramatically and became invisible until impact. And on February 13th, just 7 hours after its discovery, asteroid 2023 CX1 slammed into Earth's atmosphere at an incredible speed of 9 miles per second, or 14.5 kilometers per second, traveling east over the English Channel towards the coast of Normandy, France. It experienced a huge amount of atmospheric drag, which caused it to violently fragment. The fragmentation was witnessed by observers on the ground as a big flash. It also produced a huge amount of kinetic energy that produced a shockwave that was audibly heard by some witnesses and was detected by French seismographs. As the fragment slowed enough to stop burning in our atmosphere, it disappeared again at an altitude of about 12 miles or 20 kilometers as it entered what is known as dark flight. The fragments continued to slow until they came to rest in a stern field in Normandy region. Search efforts started almost immediately. Landowners eagerly cooperated with the hunters, and on February 15th, an 18-year-old art student found the first piece in a field, and it weighed about 3.4 ounces. Many more pieces have since been found and have been generously donated to universities and museums. This is the 7th asteroid discovered and successfully predicted to enter our atmosphere, and only the 3rd one of those that we have ever recovered meteorites from. A sample of this meteorite was submitted for classification, and it has been classified as an L5-6. That's not an exceptionally rare classification, nor is it an especially beautiful meteorite. But because of its amazing story, predicted entry, and low total known weight, this is going to be an especially rare and expensive meteorite. I wondered if they were able to track 2023 CX-1's trip through space before we bumped into it. And I learned a new fact. I learned that it was on an Apollo-type orbit, which means that it crosses the paths of Earth and Mars. It had an orbital period of about 2.8 years, and the last time that it made a close call with Earth was in June of 2000. So it's been out there, it's been our neighbor, and we were just finally lucky enough to bump into it. It was a bit dramatic and kind of exciting, witnessed by lots of people, but we were just really lucky to finally bump into it and get free samples from space.
Yeah, wow. And it was so projected, we actually had people set up their telescopes and cameras and film it, waiting, expecting for it to come in. Wow. What a fantastic job you did, Allison. I'm so happy.
Over 30 observatories witnessed it coming in, not to mention citizen scientists and people who happen to catch it on doorbell cams and things like that. So yeah,
Very
super
cool.
exciting event.
Yeah. Well, I'm super glad that you shared that story with us. It is a really super special story. As you said, it's only the 3rd time we've ever tracked and recovered something before and after it was in space. So, yeah, you made that story come alive. I really appreciate it.
Yeah, thanks for letting me share it.
Absolutely. And we're going to bust into a little bit of show and tell and take a look at some of these samples, I think. I luckily have a small piece that I'm going to share with the crew. Not share it with you, but virtually share it with you. So here is my COA. And again, it's a provisional one because I got this right away. But it has the date that Allison mentioned, February 13th. Total known weight at the time was only less than 800 grams. So I don't know if that's been what it was published as. Hopefully
1,200 grams.
1,200 grams. So a few more pieces were found. This is actually a piece that hit on the tennis court. So I have a hammer piece. So the weight of this hammer fragment is just over 1/3 of a gram or just under 1/2 a gram, however you want to look at it. And this is a really beautiful sample. So it shows some shock elements in it. You can definitely see chondritic formation. And unfortunately mine, although it landed in a tennis court, doesn't have any fusion crust nor any color of the tennis court embedded on the meteorite. But I am super happy to have this sample. And yeah, very, very, very fortunate to have part of the 1,200 grams that was tracked here to Earth. So, all right.
Yeah, it's very nice looking.
Thank you.
And now we're going to jump into Antarctica. I'm just going to give you a quick update on the Antarctic meteorites. So first, we're going to touch on ANSMET. And ANSMET is the Antarctic Search for Meteorite program. It's a U.S.-led field-based science project that recovers meteorite specimens from Antarctica. And since 1976, ANSMET has recovered more than 23,000 specimens from meteorite stranding surfaces along the Antarctic mountains. As you can see on the map there, you can see, where most of the meteorites in Antarctica are usually found. There's a lot of strewn fields in that area between West Antarctica and East Antarctica. After ANSMET, they found 140 in Dominion Range. There weren't too many stand-up meteorites this time, and if you don't know, in Antarctica, all meteorites are every specimen is entered as its own classification. So I think they might be doing that in Chile as well, very recently, but definitely in Antarctica. And so out of the 140 classifications, there was one standout, and it was a carbonaceous, a CVB, a Ben Cubbin, and it is only one of only 6 classifications. So that's pretty cool. So the following that, I think those dropped in April, and then the following month, the Lost Mets dropped theirs. They had, I believe, 16 meteorites. So they, theirs came out in April. So the ANSMET ones came out in March. Sorry about that. So Lost Mets is the Lost Meteorites of Antarctica project, and that's a UK based project. And they did not find their meteorites in the same area that most of the scientists found them. So I'm going to try to show you exactly where. And I had to pull up several different maps to get this to really, I guess, drive the point home. So they found most of their meteorites, 15 of them in the outer recovery ice fields, and then 1 in their Hutchinson ice field. So on this map, you can see that I have most of the normal strewn fields. You can see the DOM is the Dominion one we were just talking about, right smack dab in the middle of all, it's Grand Central Station down there. But if you look up where the blue circle is, that's where the Lost Mets are. So let's go to the next map, and we'll go in a little bit deeper. So you can see here, I have the green arrow is pointing at the recovery glacier, and the yellow arrow is pointing at the Schlesser Glacier. So it's going to drive the point home even more. So I have the yellow, where the yellow box where the yellow arrow is pointing to, and same with the green. And the black boxes show you in relation to those glaciers where the UK stream fields are. So I had to pull up a few different maps to get it down to that level. So they're not looking for meteorites where everybody else is, but I think that's pretty cool. And then there's one more meteorite that was classified in Antarctica, and that is by the PNRA. PNRA, the letters are a little bit different when you read them out in English, but that is the National Antarctic Research Program, and that's from Italy. So that's Programma Nazionale di Ricerche in Antartide. And I'm sure that I butchered that, but
Wow.
but that's how the letters are a little bit different in English. So they dropped one in July, and so they were down in the normal area. This was on the McKay Glacier. They found a carbonaceous, a CM2. So that covers all of the Antarctic meteorites that were found through the July 29th update. So let's take those Antarctic meteorites out of the mix, and now we're left with 1,076 meteorites to still cover.
These are the fun ones because we're actually allowed to own these.
Yeah, cool.
Yep. Okay, so first let's cover the locations. So first, can anybody guess where the most meteorites were found? This is second place, actually. But yeah, 405 in Northwest Africa. There is one, they're usually in first place, but there is another location that beat them out this time. But we'll get to that in a little bit. So, all right, moving on to the United States. We had 6 meteorites that were approved and published, 3 in Nevada, no surprise there, 1 in California, 1 in Tennessee, and 1 in Florida. And so for the North American continent, that was it. Believe it or not, nothing from Canada or Mexico in 2023. Canada's last meteorite that was approved and published was in the late 2022. It was a witness fall called Golden. And then I looked up Mexico for the last year, and they haven't even had one classification published in the last calendar year. So I'm not sure what's going on down in Mexico, because I know that they have plenty of meteorites down there. So hopefully we'll find out more information about that as time goes on. So going a little bit more south, we are down South America. And yes, here's our winner so far for the year. 568 meteorites classified in Chile. Now, That's kind of crazy because that brings their total to 2,925. So yeah, about a sixth of their meteorites were classified in the last 6-7 months. What's going on down there? I'm not exactly sure. So we had Chile, and the other country in South America that had one was Peru, and that brought Peru's to a total of 13 meteorite classifications. So that's exciting for them. Moving on to the Middle East, we had one in Oman, which is pretty crazy because Oman has, I believe, over 4,000 classifications. I know that they changed their laws, export laws recently, so you can see that in the numbers now. We had 16 from Iran and 2 from Kazakhstan. So Kazakhstan, that brings their total to 24. And I was looking at my notes, and yes, I was right. Oman has 4,020 meteorites, including the one that was just published this year. So they kind of slowed down quite a bit. Wonder why. But moving on to Northern Africa, we're just going to cover a bunch of countries here. The few things that stood out to me were Egypt only has a total of 128 classifications, believe it or not. So having 15 this year I think that's a considerable jump for them. Niger only has 108, so 12 is another significant upgrade for them. And then I thought it was weird that Libya only had 2 because they have a total of almost 1,600 classifications. So yeah, I've seen some weird numbers. Morocco had a lot at 84, but I've heard that will be slowing down. So we'll see. Time will tell. And then we're going to go down to the southern part of Africa. And we had South Africa had 2. It brings their total to 49. And believe it or not, Kenya had 1, and that brings their total to 12. I always thought there were more meteorites there, I guess probably because of Saracho, but yeah, that's only their 12th meteorite classification. So now we're going to jump over to, again, I'm covering Japan and China and Australia here in this update. So Japan had 1, it brings their total to 58, which I was really surprised because Japan has been following meteorites like from the very beginning. They're the very first witness fall, I believe, and one of the first classifications in the MetBull is from Japan, and it's from the year 861, and I believe it's called Nogata. So I'm surprised that they haven't found more there. Australia had 1 all year. I believe that some laws changed in Australia too. So as we're seeing these export laws changing in different countries, it looks like it's going to be harder to get classifications published. And then China had 21, which is about normal for them, bringing their total to just under 500. Then we have Europe and Russia. Russia is one of the transition continents. It's part of Europe and part of Asia. So they had 2, bringing their total to 154. France had 1, bringing their total to 48. Finland had their 12th classification, and Sweden had 1 as well.
That was just the mass update on Twenberg, right?
No. There was also a find there as well.
Oh, awesome, thank you.
All right, so now we are at classifications, and so I'm adding back in the Antarctic meteorites, even though we had taken those out before. But I wanted to give you a full, clear picture of everything that has been classified. So we're going to start with the achondrites. Achondrites typically make up about 8% of all meteorites, and that is 1.7% the primitive and 6.3% are the evolved achondrites. As you can see here, all the achondrites that were classified. The standouts were the primitive ungrouped. We had 2 of those this year, and that makes a total of 4. There's only about 1.5 kilograms of material between all 4 of the classifications. And then the enstatite chondrites, that was the 12th of those classifications. So some rare stuff, but not too many there. But moving on to the evolved chondrites, which include lunar, Martians, and the Vestoids, which I've kind of listed out separately. So let's look at the HEDs first. And if you don't know what those are the Howardites, the Eucrites, and the Diagonites. or as Oz likes to say, Diogenite. We had a new classification as of December 2022, but now we have another one, the Howardite Melted Breccia. So I believe that was the second one that the one that we had in 2023. The Diagenite Melted Breccia, that's one of 8. So as far as the rest of them, they're not too rare. So let's just move on to the lunars. We have a new lunar classification that we haven't had before. So far, there's only one meteorite classification under this, and that's the lunar norite. We had some lunar proctilectic northsite, and that is 1 of 6. And then we had our 13th lunar gabbro. Moving on to Martians, there's not too much to report as far as Martians, just 1 Nauclite and 8 Shergotite. If you need some Shergotite, just let us know because we have plenty of Gala 001 available. All right, so moving on to stony irons. So stony irons account for about 1.2% of all meteorites. And these percentages I'm giving to you are from about 2 years ago. They may have changed, but overall, these numbers stay pretty close to the same.
If I remember correctly, these numbers are based off of the number of classifications, not the weight of the meteorites.
That is correct.
Okay.
Yes. Thank you for making that clear. For the mesositerites, we had a lot of rare mesositerites come up. The A2s, that's 1 of 6. The Bs, that's 1 of 7. The A3, 1 of 11. The B2s, 1 of 10. The Cs, 1 of 9. And then for pellicites, there weren't as many rare ones, but we did get a new ungrouped pellicite. So that's 1 of 11. Neat stuff. So moving on to irons. I hope Ron's paying attention. So there are 2 kinds of irons. We don't usually talk about the different ones usually, but they're silicate bearing and fractionated. We have the IAB complex and IAB main group. Those are silicate bearing, and the IIAB and IVA are fractionated. And so I'm honestly not exactly sure where iron or ungrouped iron fall in there, if it's either one of those or if they're outside of those 2 main categories. That's something we'll have to ask Mike Kelly about at some point. So let's move on to the carbonaceous meteorites. And so carbonaceous meteorites make up about 3.6% of all meteorite classifications, and they're considered outer solar system meteorites. And we did have some rare ones come up with the carbonaceous this time around. So CL3 is a brand new classification, and we had 1 of those. For the CK5-6, we had 1 of 2 classifications this year. And the same for the CO3.05, 1 of 2. And then lastly, the CK5/6 is 1 of 7.
Wow, this is some rare stuff.
Yeah. All right, so moving on to chondrites, and this is what we consider mostly the ordinary chondrites. But what I've included here, these are all inner solar system meteorites. So what I've included here are the enstatite chondrites, which make up about 1.5%. The ordinary chondrites, and what I've included in ordinary are the H, the L, the LLs, and the Rumarudes. And those make up almost 80% of all meteorite classifications. No surprise there, though, right?
Mm-hmm.
So jumping over to the enstatite chondrites and the Rumarudes, we had 1 Rumarude that was rare, and that was the R4-5. It's 1 of 6. The rest of them aren't super rare. But for the enstatites, 2 of them are 1 of 9. Those are the EH5 and EH6, and the EL5 was 1 of 10. But what was really interesting is the OC4 Melt Breccia. We had 4 of those, and they were all approved this year. And we have some of that in our inventory if you're interested.
We actually have the one that the others are paired to. So we have the original, the OG.
The OG. Yes, that's correct. All right, so let's look at the H chondrites. We just had a few that were rare. The H3.15 as one of 3 classifications. The only other ones that were rare were we had 1 of 10 for the H4 melt breccia and 1 of 17 for the H/L4. So moving on to the L chondrites, we had a lot of L chondrites classified, and really the only one that was rare is the L5-7. That's 1 of 3. And lastly, the LL chondrites. Now we do have some rare classifications here. So the LL4 anomalous, that is the one and only. So that's a new classification this year. And then the other ones were 1 of 6 for the LL6 anomalous, 1 of 9 for the LL4/5, 1 of 10 for the LL3-5, and 1 of 12 for the LL melt rock. So that's your update for the 2023 year to date. And we'll be coming back with part 2, where we're going to get into like interesting stories about certain meteorites and their backgrounds. Like I said before, Pat's update from the MetSoc. And I'm going to probably get into a little bit more detail with some conversations I've had with different meteorite buyers and hunters, and how they choose who classifies their meteorites. So stay tuned for that.
Awesome
Thanks
job.
so much.
Awesome
Bye.
job, babes. You really do a lot of research to put these MetBull updates together, so appreciate it. And Allison, as always, you're a valuable crew member. Thank you for being here again and doing a great job supporting us.
You're the best, Allison. Thanks so much.
That was awesome, Sue. Thank you.
Thank you.
Remember, everyone, we rolled out memberships on our YouTube channel now. So click the blue join button and pick a membership level to support ongoing education for meteorites. And go out to patreon.com, search for Topherspin Meteorites, and can support me out there as well. I would really appreciate it. We can keep going with our meteorite videos, making a lot more for you. Have a great night, guys.
Thank you. And Allison, thank you so much. You were the perfect person to tell that story.
No, it's so exciting. I could barely talk. This is the 7th asteroid discovered and successfully predicted.
Wait, say that again? It's a
Yep.
sex one? It's the sexiest one?
It was so sexy. So sexily
Freudian
predicted.
slip.